Okay guys, we took a look at how we can expand logarithmic expressions that contain products, quotients, and powers. And in this video what we're going to look at is just some of your exercises in which we're going the other way around. And so that being said, we're going to be taking these expanded expressions like the ones here on our properties on the right and putting them back into a condensed expression as a single log, or hopefully a single log. And so that being said, keeping in mind that we're going the other way from expansion here, and with expansion we look at quotients first, products, and then powers. We tend to look at it in the reverse order here with condensing, or to condense things. So to condense, this is kind of like a general set of guidelines, but we would say look for powers first, and then products second, and then we'll look for any quotients last. Okay, so quotients. And so as we look at these things, starting with, say, letter B here, we say log base 5 of 8 minus log base 5 of t. It requires us to think back to our properties of logarithms here that say, well, first of all, if we rewrote this as a difference of two logs in the first place, then what we had was a quotient to begin with. And so since that's the case here, we have log base 5 of 8 minus log base 5 of t. The thing here is we can take both of these logs and we can rewrite it as a single log base 5. It's just that we recognize that we have a quotient here. And with respect to our quotient, remember that order matters. That is to say that log base b of x over y is log base b of x minus log base b of y, because x was in the numerator and precedes y that was in the denominator. In this case, we're going to say when we put this back together, the 8's going to belong on top here, and then our t is going to belong here. So this would be our condensed expression, simply because we have no other logarithms that we could fit in with this one right here. Now, with respect to this next one here, we're going to see that we look for powers first. What I mean by powers is, recall that when we expand logarithms, those powers are these things that we're continuously carrying out in front. But in this case, because we're going backwards, we're going to put our powers back first on whatever we were taking a log of. So we would have log base 2 of x to the power of 2, and then plus log base 2 of y, but to the power of 4. So you can see that we put our powers back. Now, with respect to what else we could do with these two, I suppose we are adding these two logs together. And so because we have an addition of two logs, really what we're looking at is our product property here, which says, well, then you can write this as a single log base 2 of the product of our two arguments here. And our product would include the x squared and the y to the fourth. So we say x squared times y to the fourth. Here would be our product. And again, we would say that this is as simple as we could go, just simply because of the fact we have no other powers to put back or logs to combine with this one. So looking at letter I, kind of like letter C, except for that when we look at this here, we see we have three separate logs and some powers out in front. So, you know, starting by using this order here, of course we would put the powers back. We would get log base 3 of x to the third power plus log base 3 of y to the fourth power plus log base 3 of z to the fourth power here. And so we've thrown all these powers back up on top of the arguments in the log. What we want to do now is, looking at these sums, see that we really have a product property going on. So because these are both sums here, what I'm going to do is I'm actually going to combine all three of these at once, which is not always possible, but because these are all sums, we would say that really then we must have a single log base 3 that is the product of these three values right here that we were taking logarithms of. And so we would say log base 3 of x to the third times y to the fourth times z to the fourth. Excuse me. And so this would be our condensed logarithmic expression. And so lastly, letter H here. Again, looking through this and scanning, we see, do we see any powers here? And so I've spotted a power here and a power here. So I'm going to start by initially putting those powers back. And so we would have log base 10 of x, or just log x, minus log of y squared. So we put our power back up there, plus log of z to the third. And so looking at this here, we would say, well, now what would you want me to do next? Now typically we would do addition and subtraction from left to right here, but what I want to do is I want to put back our products first. And so what we end up with is log x minus, now this would be a single log, and we would have the product of the two things we were taking logs of before. So we have y squared times z cubed here. Now looking at this minus sign, this would imply that we could put these two logs base 10 here in a difference with one another back as a single log of a quotient. So we have log base 10 of a quotient here, where on the top of the quotient we have x, on the bottom of the quotient we have y squared z cubed, and this would be our condensed logarithmic expression. Cheers.